Okay, for problem number 4. In the figure, a 50 millimeter pipeline leads downhill from a reservoir and discharges into air. If the loss of head between A and B is 44.2 meters, compute the discharge. Okay. So, as you can see in the figure, no? Diba, ganito ang tendency ng reservoir. Nakakita na ba kayo yan? Tangke. Kahit sa mga bahay, kung meron kayo water tank. So, kung wala sa mataas na elevation, say for example, this figure is 45.7 meter kanyang taas. So, nagdi-discharge siya ng, ano ba to? Ng liquid or fluid na di pa natin alam. So, magdi-discharge siya, syempre pababa at hanggang makarating siya at point P. Tapos, ang kanyang diameter daw ng pipe is 50 mm. Tapos, may given din na head loss. So, sulat natin muna yung given from the problem. So, the diameter is 50 mm na nga. So, 50 mm is also equivalent to 0.05 meters. So, divided by 1,000 lang po yan. So, 0.05 meters. Then, the head loss given is 44.2. So, kapag nasabi na, nasambit na sa problem ang term na head, loss of head, that is automatically head loss, HL. So, HL mo dyan is 44.2 meters. Then, considering datum line at point B, so, kung ito daw yung ating reference point, so, i-assume natin na yan yung first elevation or elevation at 0. Then, habang tumataas ka ng tumataas hanggang kay point A, so there is a difference of 45.7. No? Gets? Paano nasabi? Height lang yan. Okay? So, from 0 to 45.7. So, the difference between that, so that is 45.7 meter. That is your assumed ZA. No? And then, syempre, automatically, ZB mo dito is equal to 0. Kasi yun nga yung starting point. So, ZB tapos ZA. So, point B, point A. Okay? So, ZA, again, is 45.7 meters. And then, ZB is equal to 0. Since yun yung starting. And then, the liquid is not specified in the problem. So, we can consider na lang muna as water. No? Unless otherwise may ibang given dito. Pero hindi ko naman kayo bibigyan ng problem again na walang liquid na given. So, for this problem only, consider natin siya as water. Okay? And then, the velocity of fluid flow is inversely proportional to the area of its path. Since the reservoir has a large section, the velocity of flow is so slow, making the water inside it to be almost stagnant. Therefore, it is safe to assume that the velocity at point A is equal to 0. Okay? So, inassume natin na ang velocity mo dyan is equal to 0. Since sa sobrang laki siguro ng section, hindi man din given sa problem kung ano ang diameter nitong malaking reservoir na yan, no? Wala mang given eh. So, it is safe siguro i-assume muna natin na VA is equal to 0. Remember, free liquid surface is subjected to atmospheric pressure only. Thus, gauge pressure is 0. Since the reservoir is open and the liquid surface is exposed to atmosphere, we can say that PA is equal to 0. Diba? Natandaan nyo sa prelim. So, kapag nag-a-assume tayo ng pressure, kung ito is free surface, meaning hindi siya kulob, hindi siya exposed sa kung ano man. So, we assume that this point is 0 pressure, diba? Tapos, iba naman yung P at the bottom. So, kapag pressure at the bottom, dun tayo nagsasummation of gamma H. Recall from prelim, so we can say that VA or the velocity at point 8 is 0 and also the pressure at point 8 is also equal to 0. Okay? And then, the pipeline discharges water into air at point P. So, at point P naman, so since mula dito sa taas hanggang pababa, air na lang daw yung kanyang ilalabas, no? Nalalabas lang siya ng air dyan. So, since air siya, atmosphere, exposed to the atmosphere, we can also assume that the pressure at point B is equal to 0. Okay? So, yan pa lang mga given. Okay. To solve for the discharge, the velocity of flow in 50 mm diameter pipe should be calculated first. So, di pa natin kasi alam yung velocity, no? Pabaliktad tayo ngayon kasi 'di ba? Sabi ko sa inyo, ang principle is alamin natin yung flow tapos bago tayo mag energy equation. Pero since hindi nga natin alam yung kanyang discharge, so baliktarin natin ang sitwasyon. Unahin natin tong equation ng energy bago tayo mag-proceed sa getting the discharge. No. So, energy 1 to energy 2, considering head loss. So, VA squared over 2G plus PA over gamma plus ZA minus head loss is equal to VB, the velocity at B, squared over 2G plus pressure at point P over gamma plus ZB. Now, sabi ko, yung velocity at A is 0, pressure is 0, tapos sa point P, pressure at point B is 0. So, automatic 0 to, no? So, meron kang 0 value ng velocity, meron ka ding 0 value ng pressure, sa ZA lang. So, ZA is the difference in elevation between point A and point B. That is, ayan na po ha, elevation lang yan ha, 45.7 meters. So, ayan, given dito, 45.7. Now, ano pa yon? Given din itong head loss actually sa problem. So, the head loss is 44.2. So, the term is loss of head or head loss. Automatic HL yan. So, that is equal to 44.2 meters. Take note na lang din of the negative sign. Ano? So, kung nandito ka sa E1, ang iyong head loss is negative. Kasi ito nga yung sinusunod natin na formula. Baka lang kasi maging plus nyo ha, ingat na lang. Kasi lahat ng term is positive, diba? Iisa lang yung minus. So, pakiingatan yung HL na huwag maging positive. Ano? Kasi negative yan. Kaya nga lost diba? Nawala. So, that is deducted. Okay? So, minus 44.2 is equal to unknown yung velocity at point B, since yun yung hinahanap natin, over 2 by 9.81, and the final two terms, the pressure at point B is 0. So, kahit wag mo na siyang i-consider. And then ZB, since yun nga yung ating reference point. So, the elevation at that point is equal to 0. Okay? So, calculating that, VB squared over 2G 2 by 9.81 is equal to 45.7 minus 44.2. So, you will get a value of velocity at point B of 5.42 meter per second. Okay, ayos. And then, ayun na. So, from equation 1, okay na tayo. Proceed tayo kay discharge. So, discharge now is equal to the area of your jet at point P. Syempre, kung ilan yung diameter niyan, yun lang din yun. So, 50 mm. So, 1/4 pi by 0.05 is squared by the velocity nakuha mo doon sa energy equation. So, 5.42. And then, to calculate that, using your calculator, of course. So, 0.0164 cubic meter per second. Multiply mo ng 1,000 kung ang hinahanap is liter. So, the final answer is also equal to 10.64 liter per second. Ang dali lang, no? Substitution lang talaga siya. Marami lang, mahaba, and maraming given, pero once na makuha mo na itong energy equation saka itong discharge, so okay ka na, hindi ka naman siguro dyan mawawala. Okay, so that's it for problem number 4.